Hi, I'm Ron Ginger. In this video, I want to show you how to use the tool offset features with the new Mach 4 lathe or turn screens. In turning, almost every job is going to require multiple tools, and that makes tool offsets and the ability to switch back and forth between tools a critical feature of doing almost anything with a lathe. The lathe that I'm going to use in this video is a little machine shop high torque mini lathe. This is the machine that we used for the CNC workshop class last year. In fact, this one is the prototype machine that we developed the mechanical control for, and 14 people built this lathe at the CNC workshop last year. If you're going to do anything with a lathe and with accurate, repeatable tools, you've got to have a way to repeat the installation of your tools. This lathe comes with a 4-position tool post that is pretty accurate. It has a detent, so when you rotate it around, it returns to a pretty reliable position. I've chosen to install an Alora style tool holder on this machine. This is a pretty common, at least in the US, a pretty common tool holder. Each tool goes into its own little carrier, and when they are dropped on and locked in, they repeat quite accurately. That is, if I take this tool out, do something with another tool, then put this tool back in, I should be able to return to the settings for that tool quite accurately. And that's a critical piece of doing anything with tool offsets. So first is you've got to have repeatable tools, 4-position tool post or Alora style or whatever. The next thing is Mach needs to know precisely where the x-axis is. And to do that, I've installed a proximity switch as a home switch. I'm going to click the reference X button here, and the homing operation will start. The carriage moved out to the switch and then moved back very slowly. It's at moving back very slowly where it gets its accuracy and pickup. When I set this lathe up, I did a bunch of measurements with it. I set up a dial indicator and I did repeated homing, and I found this thing repeated every time to the same line on the dial indicator. So I think this repeats itself within a thousandth of an inch or less. So we have to have interchangeable tools, and we have to have an accurate homing position. Now, some people put a homing switch on Z, and I did on this machine, but Z is really not very useful. You'll see when we get setting up the tools that we reference Z off the end of our work. Every time we change a piece of stock, our Z location is probably going to change. Now, if you have a machine that's equipped with some kind of an automatic tool changer or gang tooling, then a Z home switch would be as important as the X is. But for a simple lathe like this, the X home is important. So we've equipped our lathe and we're ready to start doing a setup for our tools. We need to have tool number 1. It's best if tool number 1 is a tool that can do both a facing operation and a turning operation. This tool is an ideal tool for tool number 1. It's not critical that it be that. It's quite critical that it be a tool that can do facing. So my tool number 1 is a tool that's pretty good for turning and facing. So to begin, I'm going to insert my tool number 1, lock it down, and my first job will be to take a test cut with that tool to establish the reference measurement. For this lathe, I've set it up with a Shuttle Pro. This is, I think, a pretty handy jogging device. I can select the x-axis, and then as I turn the dial, I can jog very slowly, or I can jog it very fast. So I find this very handy. You can use whatever jogging device you find on your machine. So I'm going to bring the Z in here to get closer to it. And okay, I'm just slightly back from it. Now I'll turn the spindle on. Okay. the spindle motor running, I'm going to move in very slowly on the X direction until I contact the work. Okay, now I'm going to move to a Z motion, and I'm going to take a fine cut here just for a short enough distance that I can accurately measure. Okay, so I've made a cut. Now I do not move my X-axis after I've made this cut. I'll stop my spindle, and using my caliper or micrometer, I'm going to measure the diameter that I just cut. Okay, and I'll set my caliper here and come around and read it, and it looks like I cut it about 475. Before we set any tool offsets, we need to make sure that we don't have any fixture offsets in place. So I'll open my fixture offset table, look at G54, and indeed my X value for G54 is 0. The Z value doesn't matter. We're going to adjust that in a minute. But if we had a fixture offset, we'd confuse our tool offset. So we want no fixture offset. Okay, we have made our test cut. Our test value was 475, which I've entered into this DRO. I'm going to click the Set X Offset value, and a couple of things will happen. You'll see up here in the tool table that a value changed for the X offset. So we have now entered our X offset value, and our DRO has jumped to 4750, which was what we told it we were setting for. So we've entered the first tool, we've entered its offset value, and we have the tool table set for our first tool. Now we're going to move over and set our Z value, and I'll move back slightly. And here's where this tool needs to do a facing cut, although I won't take time to make a facing cut right now. I'll move in and I'll say that this is where Z0 is. Now, Z0 is going to be based on this tool and this particular piece of work. But for setting the 0, I'm going to use this entry up here, and that's actually going to set a value in the fixture offset table. So our entry for tool 1 on the tool table should always have a 0 for the Z value, and it will have an entered value for X. So we now have one tool that has been set up in the tool table. Let's do another tool. Let's go up here and do tool 0202. Do cycle start, so that gets executed. The program now thinks we're looking at tool 02. Let's set it up for tool 02. I'll first remove tool 1, insert my tool 2, which is a threading tool, and I'll jog it over in both directions. Now I'm a little bit. Again, it's best if we take a cut here, but I'm going to not take a cut, and I'm going to say that I have adjusted both X, I've adjusted X to be the same cut, 475, and I have adjusted 0 to be on the end of the Z on the tool. So I'm going to come over here, we're set for tool 2, I've entered the same number, 4750, and I'm going to say set X offset. If we watch what happens in the tool table at this time, we'll see that this value in the tool table was just adjusted to take into account the different length of this tool. And you'll notice there's quite a bit of difference between the two values in the tool table because those tools are quite different in length. Now we need to do our Z value. We don't want to change the fixture offset, but we now have the tool set to 0 for this tool. So I'm going to say to set the Z offset at this point. If we look, the DRO jumps to 0, which is correct for tool 2, and the Z offset in tool 2 has been adjusted. And if you look at the value, it says about 0.37 if you compare those two tools, you'll see that the difference in their Z value is about 0.37 inches. So I now have two tools set up. I can switch back and forth between those two tools, and the DROs should track appropriately. Let's demonstrate that. We now see that our DROs are reading 475 and 0 because of tool number 2. If I tell it that I'm using tool 0101, do cycle start to execute that, you'll notice some different values pop up here because these are the values of the DRO for this tool. This is tool 2, which is not the correct tool for our offset. So I'll go back over here. Remove the tool 2, insert tool 1, and I will, just to demonstrate here, I'll move it back to Z0 and to X about 0.475. This won't be exactly right, but if we look at our DROs, it says that we are at X 449, you know, pretty close to our 475 reading, close enough for my eyeball work. So I've gone from tool 2 settings. I put tool 1 in, told the program I was using tool 1. The offsets are automatically adjusted. I could continue running a program right now, and I'd be using the values for tool 1. So we can work our way through this with several tools. I've got 3 set up here, but you could set up however many tools you have, and every time you come back and install that tool and tell Mach 4 that you're using that tool number, the DROs will automatically jump back to them. So you'll find this is extremely useful in turning work, and I hope this made clear how you're going to set up the tool offsets to make this work. Thank you for watching my video.